Continuing our study of the atom, it's now 1897, and J.J. Thompson thinks he has made a great discovery. He's been working with a device known as a Crookes tube or a cathode ray tube, and he's come up with some data that is either impossible or requires a new understanding of the atom. This is the work of J.J. Thompson, and this is Screencast 4.3. Okay, here's the Crookes tube, as it was called. Imagine this device being passed around from university to university. Never mind that it's giving off X-rays and other sorts of dangerous sorts of wavelengths of light. But here's what it consisted of. You got an old-fashioned battery right there. And this is a tube, a glass tube that is sealed under vacuum, which is not a very difficult thing to create. You just heat it up and then seal it. A little more difficult is to do that while it has a couple wires attached, but they managed to get a couple wires attached at each end, and there's a nice strong vacuum in there, and they're applying this electric current to see what happens. So there's your vacuum tube. There's something inside once you flip the switch and turning it on, and it looks like it's light, right? It looks like some sort of green and whitish light here. But interestingly, when you put a magnet near it, it bends that light. And if you have an old-fashioned cathode ray television screen, that's the old bulbous kind of screen, you'll notice it does the same thing, though by doing it, I should warn you, you could ruin the set. In any event, it's the positive pole of the magnet moves it towards the magnet, and if you switch this baby around and make it the negative pole, it pushes it away from it. And that's weird, right? It bends light. Now try it with a flashlight and you'll find that that doesn't work. Normal visible light doesn't bend. It's not magnetic. So that's weird. Sometime later, they managed to jam a little propeller in this thing, and sure enough, when they flipped the switch, it moved the propeller, and that's confounding as well. That suggests that it has a force to it, and a flashlight or simple light doesn't do that either. Note that the heat that it creates could do it, but that's a different matter. This thing was confirmed to move a propeller based on whatever was in there. Okay, something weird is in there, and somebody needs to discover what it is. Thompson was an expert working with batteries, and he focused on the mass-to-charge ratio. And he found that the mass-to-charge ratio for small atoms such as helium and hydrogen was known, but whatever's inside this thing has a mass-to-charge ratio 1,000 times smaller than a hydrogen atom, which is of course impossible since a hydrogen atom was at that time believed to be the smallest particle known to man. He's got to make a bold hypothesis, and he does. He proposes something that he calls the corpuscle, and it becomes known as the electron. And he says there's got to be something in atoms that's 1,000 times smaller, because my data suggests that's true. And so he eventually comes up with a theory that's known as the Plum pudding model, which is simply that atoms have tiny little dots in them 1,000 times smaller than the atom itself. Those are the electrons. He has no idea where they are, and that's going to lead to the next discovery. This is Thompson's cathode ray tube experiment, 1897. This is Screencast 4.3.